Hi, in this video I'll be showing you why the vector A multiplied by the vector B equals the magnitude of the vector A multiplied by the magnitude of the vector B multiplied by cos theta. Now, so that you understand why this is the case, you first need to know that in a right angled triangle, p squared plus g squared equals h squared. So you need to know Pythagoras' theorem right here. Secondly, you need to know that cos large C equals a squared plus b squared minus c squared over 2ab. Rearranging this equation, we get 2ab multiplied by cos large C equals a squared plus b squared minus c squared. And rearranging this equation once again, we get c squared equals a squared plus b squared minus 2ab multiplied by cos large C. Finally, you need to know some vector rules. Vector A multiplied by vector A equals the magnitude of vector A squared. Therefore, vector B multiplied by vector B equals the magnitude of vector B squared. And therefore, vector B minus vector A multiplied by vector B minus vector A equals the magnitude of vector B minus the vector A squared. Okay, now that we know all of these rules, let's have a look at the diagram to my left. On this diagram, there are three vertices, the large A, large B, and large C. And on this diagram, there are also three lengths, the small a, the small b, and the small c. Now, the length of the small b is the magnitude of the vector A. So let's write this down. So small b equals the magnitude of the vector A. On this diagram, the length small c is the magnitude of the vector B minus the vector A. So let's write this down as well. So the length small c is the magnitude of the vector B minus the vector A. And on this diagram, the length A is the magnitude of the vector B. So here are a few rules that we need to use when proving this equation up here. What is also important to note in this diagram is that the angle large C equals theta, right? So the angle at this vertex large C equals theta. So this will come in handy when we're using the cosine rule up here. Okay, let's begin proving why the equation up here is true. So we'll first do this by using the cosine rule just over here. So let's write that down. So cos C, this is the angle C at the vertex C, which is theta, equals a squared plus b squared minus c squared over 2ab. Rearranging this equation, we get 2ab multiplied by cos C equals a squared plus b squared minus c squared. Rearranging it again, we get c squared equals a squared plus b squared minus 2ab multiplied by cos large C. Now, we are going to do something to this equation. We are going to change the large C, which is an angle, to theta. So let's do this. So c squared equals a squared plus b squared minus 2ab multiplied by cos theta. Now, just a little reminder, this theta is the angle at the vertex, large C, and the C that you see in this equation, along with the A and the B, are the lengths in this triangle right over here. Okay, let's use the information that we have up here in blue to change the equation below. So, we know that as C equals the magnitude of the vector B minus the vector A, C squared must be the magnitude of the vector B minus the vector A squared. We also know that A squared must be the magnitude of the vector B squared. And we know that b squared must be the magnitude of the vector a squared. And we'll use this information on 2ab. So here we'll get 2 multiplied by the magnitude of the vector b multiplied by the magnitude of the vector a multiplied by cos theta. Now, you can look at this carefully again to make sure that everything is correct. So, c squared is the magnitude of the vector b minus the vector a squared. A squared is the magnitude of the vector b squared. And b squared is the magnitude of the vector a squared. And if you know that, you will know that this equation that we've written right here is true. Okay, let's rearrange the equation below and make it a bit neater. So the magnitude of the vector b minus the vector a squared equals the magnitude of the vector a squared plus the magnitude of the vector b squared minus 2 multiplied by the magnitude of the vector a multiplied by the magnitude of the vector b multiplied by cos theta. And as I want this equation to resemble the equation we're trying to prove, I'm going to send 2 multiplied by the magnitude of the vector a multiplied by the magnitude of the vector b times cos theta to the left hand side. So I'll have this equals the magnitude of the vector a squared plus the magnitude of the vector b squared minus the magnitude of the vector b minus the vector a squared. Okay, if we use the information in brown here, we can change the equation below. So let's do that and rearrange it. So we get 2 multiplied by the magnitude of the vector a multiplied by the magnitude of the vector b multiplied by cos theta equals vector a multiplied by vector a plus vector b multiplied by vector b minus vector b minus vector a multiplied by vector b minus vector a. If we rearrange the equation again, we get 2 multiplied by the magnitude of the vector a multiplied by the magnitude of the vector b multiplied by cos theta equals vector A multiplied by vector A plus vector B multiplied by vector B minus vector B multiplied by vector B minus vector A multiplied by vector B minus vector A multiplied by vector B plus vector A multiplied by vector A. And rearranging this again, we get 2 multiplied by the magnitude of the vector A multiplied by the magnitude of the vector B times cos theta equals vector A multiplied by vector A plus vector B multiplied by vector B minus vector B multiplied by vector B minus 2 vector A multiplied by vector B plus vector A multiplied by vector A. Let's rearrange the equation once more. We get 2 multiplied by the magnitude of the vector A multiplied by the magnitude of the vector B multiplied by cos theta equals vector A multiplied by vector A plus vector B multiplied by vector B minus vector B multiplied by vector B plus 2 multiplied by vector A multiplied by vector B minus vector A multiplied by vector A. Looking at this equation, we've got vector A multiplied by vector A minus vector A multiplied by vector A. So we can cancel these out. We've also got vector B multiplied by vector B minus vector B multiplied by vector B. So we can cancel these out as well. And what we're left with is 2 multiplied by the magnitude of the vector A multiplied by the magnitude of the vector B times cos theta equals 2 multiplied by the vector A multiplied by the vector B. If we divide both sides by 2, right, we're left with the vector A multiplied by the vector B equals the magnitude of the vector A multiplied by the magnitude of the vector B multiplied by cos theta. And this is exactly the same as the equation we are trying to prove, right up here. So this is how you prove that this equation up here is true. You probably won't find this proof in any maths books, A-level maths books. I certainly haven't. If you have any comments about this video, please leave them below. Thank you very much for watching.